All right, thank you so much, Minister. And what I'd like to have now the speakers from this session to come up to the podium. And so I'm going to go ahead and invite you to unmute, so you can just speak up if you want to make a comment or raise your hand.
Thank you.
Oh yeah, good. I hear you. So I'm gonna, so if you want to raise your hand, I'll see if you want to comment on anything that's being asked. Okay, so go ahead and line up for questions, folks.
I have a couple of comments. One is on the high altitude aurora. Very glad to see that with Bernie and I are here. We of course worked hard with SME data at the time and considered the observation of the high altitude aurora to be a discovery at the time, and you're sort of confirming that. It was ironic because we could never get any of the magnetospheric people interested in studying it, with one kind of minor exception. Somebody gave a talk on it, but I don't think he ever wrote a paper on it. I'm very glad to see that the aurora is of scientific interest, not just something to be subtracted from the punch images. The other comment is for Wei-Lu. The comets, of course, you were emphasizing the near-sun observations of the comets, but of course, there's also the farther out observations where you'll be able to see the comet, of course, very, very well from punch observations, a lot of comets. But of interest, with SME, we wrote a paper on a disconnection event, where you get a CME that goes over the comet and the tail disconnects. Very interesting. You get interesting timings and speeds of that. And it was also observed by stereo. Stereo will be part of 3 of these. So I just wanted to comment. That's an interesting thing to observe about comets.
Go ahead.
Just answer to that comment. Yes, give us your light contamination. We want to use it.
Thanks, that was an impressive, eclectic description of many different science topics for PUNCH. It's great. I have a question on the aurora. So I know it's polarized, but I don't know how well it's measured or varies. What do you hope to learn from the polarization light from PUNCH?
So the best answer right now is I don't know. At this point, I want to see the data. I want to the data is not going to be seen. So we're probably in our minds simplifying a lot of it. We don't know exactly where this is occurring, not only in altitude, but also geographically. I don't think the polarization should be an issue. Yeah, but I don't have a straightforward answer without getting into trouble right now.
The dust seems extremely interesting. And we're like, it's this dust, what's the dynamics? Is it just kind of very orbits? Is there almost like a thermal component to the motion? How's it evolving? Is it moving in, being blown out? Is it being repopulated by comets, bringing in more dust all the time? Small meteorites?
Yes, the answer to that is that we are in I think a situation of dynamic equilibrium, that the loss of the dust due to sublimation, collision, and then going down to the considerable beta that get blown out by radiation pressure.
Once they get small enough, the grains get small enough, then they're going to get blown out.
They get blown out.
And what would be that size, do you think, that the smallest they go down to further?
That's less than a micron.
Okay.
And that's what the field instruments saw a lot of. And in fact, they confirmed that sublimation zone, because so much is disappearing and sublimating and small objects and getting blown out. And they saw an increase as well in the field's impacts, beginning around 35 kilometers.
Okay, so stuff that's coming in larger bodies, especially breaking up, must be a significant source of larger grain.
Yes, that's what I believe.
Okay, and so there must be some blobbiness maybe to that distribution, or maybe it smooths out pretty quickly.
We do not see much in the way of structure. We don't
Okay.
see the actual structure with our visible light stuff. So the field instrument does see, and as well as on stereo, do see hits on their antennae, of which are what, 30 meters or so, I guess, or maybe 10 meters, 30 feet, something like that. And they see a voltage spike occurring, and there are different sizes associated with that. You know, we do not have I think there is a dust instrument or mission being developed and will launch soon, going to FACON, and elsewhere, I guess.
Fascinating. So it's almost like sand on the beach, right? And you constantly are breaking up
Yeah.
rocks, making smaller
Yeah, yeah,
grains,
yeah.
and as they get small enough, they just
Yeah.
get washed away.
And then just, well,
It looks like a sandy beach.
picked up my souvenir for hunters and.
Okay, cool.
Have you thought about the seasonal effects? Because Punch is on the Terminator, but then, you know, when it's whatever, something, summer. Summer in the northern hemisphere, you know, we'll see more of the oval, but then we'll see less of it when we're going around the southern pole versus the equinoxes. Have you thought about how we can use that asymmetry to help disentangle some of this?
So, yes, I have thought about it. It's a problem because when we have like daylight in the aurora with some of the instruments that we use, we can see the aurora. However, what they didn't mention is the MSP on top of having the value of computation data. They also have optical data. So we could use other instruments that allow us to see the aurora. So I have thought about it, the instruments that we can use in those situations. However, I'm looking forward to the dark winter, because the dark winter is the best time to observe the aurora, whether it is in the aurora wall or the going up. So definitely less data in the winter, but there are ways to overcome those issues.
Question for Ray comment. A while ago, NASA has been communicating via Facebook about a comet detection challenge. And they basically had a challenge to ask, you know, the community to come up with solutions to detect these comets, and they elected a winner. They said then they would communicate about the winner and his or her method. But I haven't heard actually from that. I know someone won, but NASA didn't communicate as of, you know, didn't follow up with that. Are you aware of that challenge?
Actually, no, I wasn't, I could ask around.
That would be great. They could actually help me in the flow tracking thing to I don't know how many of these connects we're going to see, but if they are, they will be counter streaming probably with the normal flow of things. So we'll start seeing things moving backwards. And, you know, as I discussed earlier, things that are going sort of against slowing or things people may care about, but it's important to know if how we're seeing actually a comment and not something else.
Okay, great. Yeah, so that's very interesting. Because actually, I guess I wasn't involved in that section.
Okay.
Has run very good. Carl Aspen in NRO, he's doing the sun grazing comet campaign. He has been saying like 5,000 comments from the STSW vision for tracking. So the numbers will add, keeps adding every single month, every single day.
It's an impressive number.
Yeah, so things are getting there.
Okay. Thank you.
Question about dust. But if dust is charged, it can be picked up by the solar wind, and then it's pretty heavy compared to the plasma. So it can, kind of, there have been possibilities of it retarding the plasma. You know, if you had more hits, perhaps, probe, and at that time, you might be able to see some sort of deformation of the maybe see it in the shock. I'm wondering if there's any evidence of that from. Oh,
I don't know if deformation of shocks, the dust is definitely charged. What we see is the effect of that charge creating a Corning-Robertson effect that causes the inclination of that dust orbit to change. And it's just, the serial just showed that beautifully. It's really impressive. So and that begins at around, I thought, at around 30 solar radii, 40 solar radii, in that range. I'm a little bit vague, but it's in that area of
there have been thoughts that it might happen at 1AU too, but
the charging.
charging. Chris Russell, basically. Awesome.
It could be. What I'm saying is the effect that we saw was on the Sporting Robertson, changing the dynamic work. So that's a combination of the charge and the magnetic field. So the magnetic field has to be large enough for that effect to occur.
What we also saw in Ionosphere probe, that whenever you have a CME, particularly the fast ones, they don't only sweep the plasma, they also sweep the dust.
Only on one.
Only one, the first one. I think the one that happened after it, I think we also, there is evidence for it as well. So the first ones we keep.
But the mechanism for that is totally unknown.
Yes.
And the idea of charge is probably not the reason. That was the reason that these two guys gave in 2003 or 4.
I also had a thought about the aurora. You showed the aurora that probably more or less around that suggestion. But we also saw things that looked like they followed the magnetic field lines. And so you should be able to see that from PUNCH. And at least if you're looking through the aurora hole behind it, you'd be able to see that and perhaps see the distance. We were a little more able to do that because we were 90 degrees from the sun. But you could still should see partial stripes or whatever that come through. It should be connected with something over.
Forgot to mention that there are also the pillars. So I think the paper reported 2 types, and I think the pillars, more or less, I think in the magnetospheric community, those are recognized. Whether or not they're the same, I'm not sure right now. Definitely.
Yes, that's an alternate way of trying to explore that. And before SME, we asked astronauts if they'd seen aurora. Oh, it's too old. But it was the contamination that worried us the most, especially. But when it was geomagnetic storm, because you didn't want to, you couldn't see through it basically, or you had to remove the aurora where it was present.
say that the effect of the CMEs does affect the ion tail and rarely the dust tail. I think I mean, it has happened a few times, and that's something definitely to watch.
All right, I want to thank our speakers again for a fascinating session. And now I'm going to turn